Hi my dear students, welcome to Engineering Surveying 1 module. CIVL 002 is the module code. I'm here to start the first topics in the civil engineering surveying module. So here the chapter 1 is leveling. So this is the learning outcomes of this presentation. Once you complete this presentation or once you learn this presentation, you must be able to identify the procedure of conducting leveling. You can be able to calculate the heights using height of collimation method. There are two types of method, height of collimation method and rise and fall method. So in this presentation we are going to deal with height of collimation method first. Next class we will go with rise and fall method. Next thing, the student can be able to discuss the effects of collimation error and collimation test procedure. Introduction. Leveling is the way to determine the height of points above or below the ground. See, if this is a ground surface or this is a ground surface, leveling means you can determine the height of a point which is above the ground or below the ground. This is what is called as leveling, above or below, and agreed datum. Agreed datum. What is datum? Datum means assumed level surface or line that will be reference to other points. See, this is like a reference line. This line is known as datum. You can see one line here. This is datum, and this is the new word which is known as benchmark. See, what is benchmark? Any permanent reference points have arbitrary height assigned to it or had an accurately determined height determined by the leveling. Simply we can call it as the benchmark is the known elevation. When you want to start survey, you should know a known elevation. If you are starting survey from a known elevation, that point can be called as benchmark. RL means reduced level. This is the word which we use regularly in the surveying. So please remember this word. RL means reduced level. BM means benchmark. So this means RL of benchmark, reduced level of benchmark. Here you have point A, that means that reduced level of point A. Here temporary benchmark. Generally temporary benchmark established in the construction site has an arbitrary datum. It is if you don't know any datum exactly, or if you don't have any benchmark exactly, you can assume a benchmark and you can start surveying like that. That is known as temporary benchmark. Generally in the college, when you do practicals, we give you some assumed benchmark. So these are all known as temporary benchmarks, but for the purpose of calculation we consider that as benchmark. Okay, this is the basic principle and you should concentrate clearly here what I am explaining, because the principle of leveling is the height of plane collimation method. This is the height of plane collimation method. So see here, you can understand this. This is the green line is the ground surface, and you have a point A and you have a point B. So you need to define the difference of height from point A to point B. Here this equipment is known as auto level. So we have set up an equipment here and we put a staff here. I will show you when you come to lab what is this equipment and what is this staff, and if possible I will bring the equipment to class and I will show you in the class before you start the activity. So please listen carefully. Whatever I am teaching here, you are supposed to do it as the activity in the classroom. Okay, so the staff has been kept at point A and point B. So when you sight from the instrument, you can see one point. So that is known as R1. So RL of A means reduced level of A. R1 means the staff reading at A. R2 means the staff reading at B. So now the important thing is BS and FS. BS is known as backside and FS is known as foresight. So in the next slide we can get the definitions where we can clearly understand what is backside and what is foresight. You can see here staff readings R1 and R2 are taken from the instrument. If you can see on the staff, you focus on the staff, you can see R1 staff reading at A, R2 staff reading at B. Here we are having formulas. you have to calculate the height of plane collimation. Height of means not measuring with the tape the ground level. The ground is uneven. You need to calculate the height of this line. This line is known as collimation line. So you need to calculate the height of collimation. How you calculate the height of collimation? The height of the plane collimation. You can see, follow my mouse here. Here the height of plane collimation, it is known as HPC, height of plane collimation at I1. I1 is the instrument 1, is RL of A plus R1. See, it is like, see, if you want to calculate this height, you know this RL of A, you know the staff reading. RL of A means here RL of A plus R1. If you add these two things, the height of plane collimation you can get. So the formula for the height of plane collimation at I1, so I1 is here, but generally the formula for the height of plane collimation is RL of A plus R1. So now the next, you know the RL of A here, reduced level of A is known. The unknown value is the reduced level of B. How can you calculate the reduced level of B? You know this height of plane collimation, you know the staff reading. Where is this point? See, from this height, if you deduct this height, you will get RL of B. What you have done to find this height, you know this RL, you have added this height. From this RL, you add this height, means you can get the height of plane collimation here. So from this height, if you deduct the staff reading R2, you can calculate the RL of B. That is the formula here, height of plane collimation minus R2. The height of plane collimation minus R2. This is the basic principle of leveling. Here the important definitions which can be asked in the examination, and everyone should know this. You can lab practical. If anyone asks you the questions also, they will ask you this first. What is backside? Backside is the point back the level. It means you can observe here backside. When you set up an instrument, when you take a reading on the known point, okay, when you take a reading on the known point, generally the known point is again known as benchmark. So I can correlate this. If you have taken reading on the benchmark, the first reading of the survey can be written as backside. Generally, when you are going with the number of instrument stations, then if you have taken staff reading on the known point, then it is known as backside. Foresight means is the point face the level direction. See, level is going in this direction, So when you look backside, that is backside. When you are looking in forward direction, that is foresight. That is the difference between backside and foresight. Next one is the change point. Whenever you change your equipment, that is known as change point. The change point is the point where we change the position of the level and have two reading. It was foresight point from the first position and become backside from the second position. In starting, it is a bit confusing to understand. If you concentrate clearly here, you can understand what is the change point. See here, first the instrument has been set up here. He looked at the known height, that is written as backside. So when you look front, this is intermediate side. But here you need to concentrate one thing. The instrument has been changed here. The instrument has been changed. When the instrument has been changed, the reading taken on the known elevation is known as backside. The reading taken on the unknown elevation is known as foresight. I'll try to explain it on the board so that you can understand clearly what is backside and what is foresight. I'm here to explain about BS, FS, IS and CP. BS means backside, foresight, intermediate side and change point. So as I explained you in the PowerPoint presentation, the definitions of backside, foresight, intermediate side and change point is written there. I just want to show practically how it looks like. If assume it as a ground surface and take a point A. If this is a known elevation, this can be called as benchmark. The reduced level is known as RL of benchmark. Okay, here the concept is that if you need, you can put staff here. If you can put staff here, if you take instrument, if you set your instrument here, the first you have to take the reading on the benchmark. The first reading taken on the benchmark generally. The reading taken on the benchmark or the known elevation is defined as backside. You should remember this. This is a very important point, that when you set up an instrument, then you take the first reading or you take the reading on the known point is known as backside. Then if you are having n number of points, okay, the next point which you have seen generally called as foresight, but there is a condition where foresight and intermediate sight differs. Generally the last one will be the foresight, and the readings between the backside and the foresight are generally called as intermediate sight, because these are intermediate sights between the backside and the foresight. You should know when should you write the value, means when the staff reading should be written as foresight. When can we write this as a foresight? See this, for example, this is A, B and D. After D, if you are not able to see the next reading using this instrument, for example, take this as instrument 1. From the instrument 1, after D you have some other instrument E. If you are not able to see E because of any curvature or because of any obstacles, then you need to change the instrument from here to here. You need to change the instrument from here to after D. So in this condition, when you are going to change the instrument, the last staff reading is noted as foresight. So when you are going to change the instrument, the last staff reading it should be noted as foresight. So just imagine, once you have changed the equipment, this is not the old one. Now I will draw it from E. You have seen the diagram there. So the last reading we have taken is D. Now you are coming previously from here, the survey, you have instrument 1 here, and you have A, and you have B, you have C and D. This was the previous one. So this is instrument 1. Now you have set up the instrument, new instrument, that is I2. So now once you change the instrument, you should take the reading again back on the D. So now from this instrument 1, you found the value of D, means you found the RL of D. Now you know the D elevation. So with I2, this D becomes backside. Now you have to check back again. From this I1, this D is foresight, but this from I2, this D becomes backside. So this D can be written as CP, is change point. So this is the basic logic, that a change point will have both foresight and backside. I will just brief you that. See, when you are seeing from the instrument 1, you have taken backside at A, B intermediate sight, C intermediate sight and D. You are not able to see the next station after D from this instrument. In this condition, you need to change the instrument from I1 to I2. Before changing the instrument, the staff reading taken on the D is written as foresight. So once you have changed the equipment I2, immediately you have to take the reading on the D, because D is the known elevation here. So from the new station, the reading taken on the D is noted as backside. So at the same point you got foresight and backside. So this is the change point. Change point defines simply that after this point the instrument has been changed. I hope you got clear understanding about backside on the known elevation. When you change the instrument, the last point is known as change point, and the staff reading taken on it is noted as foresight. The middle values between foresight and backside is noted as intermediate sights. So what is intermediate sight? Intermediate sight is the points between the foresight and the level, or between backside and the level. So you can see the foresight and the backside. The points in between one instrument station is intermediate sight. I will try to draw a diagram on the board and I will clearly explain what is this backside, foresight and change point and intermediate sight. So now coming to the types of leveling. So see, I will just give you a brief explanation. You can read these things here. Simple leveling, when you are having only two stations, where you know one station RL and you need to find another station RL, then this leveling is known as simple leveling. The next one is differential leveling. So you have continuous leveling. This is known as continuous leveling. So you have number of stations. There is a requirement to change the equipment also. You should know when will we change equipment. That is very important. When will we change equipment? Then only you can understand what is change point and all. Fortunately, before you come to the class, you will be having lab session. So I will explain you clearly with the equipment, when you change the equipment, at which condition you change the equipment and all. Okay. So differential leveling is opted. So when will you opt this differential leveling? The points are at a great distance, the difference of elevation between the points is large, or there are obstacles between the points. In this type of condition you can select differential leveling. Next one is longitudinal or profile leveling. This leveling is followed with a center line. Generally this is used for long distances like roads, canals, railway tracks, runway tracks, all these things. So we will plot a center line and we will take this backside, foresight, intermediate sight at a regular interval. So when you are doing such type of survey, you need to select profile leveling. While performing your lab experiments, we will go to some wadi near to the college. Like it's not a closed wadi, like no water is there, it's a empty land is there. So there you can calculate up to 1 kilometer distance. You can calculate the level regularly. So it depends upon the ground surface along the profile line. So these are the three types of leveling. The first type of leveling is simple leveling. The second type of leveling is differential leveling. The third type of leveling is longitudinal or profile leveling. So there are two methods, as I already explained you. There are two methods of calculating reduced levels. The first one is the height of collimation method and the rise and fall method. Next one, just a brief description about the height of collimation method. This method is based on the calculation of height of plane collimation for each instrument position. You can understand that this method is based on the calculation of height of plane collimation for each instrument position. So this is each instrument position. Here there are four different instrument position. So for each instrument position you will have different height of instrument. The height of plane collimation method of calculation can be much quicker when a lot of intermediate sites have been taken. So this is more advantageous when you are having lot of intermediate site. This question will be asked that where you can use which method. So you remember this point. Height of plane collimation method is used where there are more intermediate sites. It is a good method to use when mapping or setting out where many readings are often taken from a single instrument position. So this is the brief description about the height of collimation method, and here we have some example problem. I will explain it in another video. So only specially I will prepare a video for that problem. See you again. Bye.